0. And then you carry this what? Down, and you're going integral 2x plus 2 dx. This will give you the volume. It's integral 2x.
X squared plus 2x.
So what's the volume underneath that ramp over that rectangle region? See,
3.
now I'm not drawing the ramp. They call this the region of integration. This is D. The region of integration. Sometimes they call it letter R for rectangle. That's that D right there. What's 1 plus 2?
3.
There it is. But do you agree this estimated volume again? Volume. If they come out negative, you and I know that over that region, all those numbers are solid. That plane's above it. So again, what did we just find geometrically? We estimated the volume underneath the surface, z equal to x plus y, over the rectangle region, 0 to 1, 1 to 2. And if I set up this problem like what? 0 to 2, 0 to 1, I still get the same answer, do you agree? What do I have to write there?
dx dy.
Oh good, dx. dy. Cool. Yeah, I'm gonna leave that up here. I'm gonna erase this. What about this? How about I've got 0 to 3, 0 to 4. X squared y squared. Or what did I do last time? 0 to 1, 0 to 2? Okay. And I'm going to do dy dx. So, everyone, if I asked you to calculate this, you could do the iterated integral, true?
Mm-hmm.
I knew you all would get it right. You would integrate this with respect to a y.
Y.
But I wanted to give you some options on how to do the mathematics. Because boy, Calc 1 was so nice when you could just do these simple single integrals, right? So, this problem right here versus this problem right here. I'm going to separate them. Get that out of the word. By the way, I had that word estimate up there. We found the exact answer. So I apologize, I still have that word estimate. This is exact. We did the actual integral, no Riemann sums. What about this? Well, you know what you could do, true? But I want to give you an option. Did you know you could split that up? I want to tell you when you can split this up. You could rewrite this as the integral from 0 to 3. The 0 and 3 went with what? X or y?
X.
X. So I'm going to write everything in terms of x squared dx. Get that answer. Multiply to the answer integral from 0 to 4 of y squared dy. So I wanted to give you this option. If you want it. So I want to give you if you prefer. Some may. This is how you can work this problem. What I'm saying is you didn't have to do it in an iterated manner to solve that problem. But over here, big wall, you had no option here. So I want us to discuss that. When are you allowed to do this? I call this splitting it up. When are you allowed to split it up if you wanted to? The first rule, these have to be 4 numbers. So that's rule number 1. So and here's the rules for split up. If you want to, because I like splitting things up, honestly. You'll see me when I'm doing this chapter. If I'm allowed to do this, I will. I just think it's easier. I'll just do that integral, multiply the two values. This can get a little crazy, right? I might mess something up. I can do this if these are 4 numbers, but this had 4 numbers. So there's a second rule. It's got to be 4 numbers, and then this has to be able to be written as that function of z, that function of x and y, z. It's going to be written as a product of x's solely times y solely. So you see what I mean? Can you rewrite x plus y as something in terms of x times something in terms of y to get x plus y?
No.
It's impossible. So here we had no option. We absolutely had to do this in an iterated manner. No option here. But if you can somehow break this up into a product of only x's and only y's, then you can do it. Now hey, if this bugs you, have no worries. You can do everything iterated. Just do everything iterated. No stress, right? But you will notice on the board, I'll ask this to up this score, I'll go, hey, can I split this up? Remember, 2 rules, this has to be written as what, a product, x's, y's, isolated solely. And second of all, these have to be for what? Numbers. Now when it's a rectangle, it's always 4 numbers, right? But guess what we're about to get into in a few minutes? We call it a general region. What if the region's not a rectangle? What if you're getting a volume over something like, you know, that? Then these aren't going to be 4 numbers anymore. Because, does that look like, that's not a rectangle, is it? When you have 4 numbers, that's always representing a rectangle. And if this is 0 to 2, 0 to 2, that's a square, isn't it? Cool. So, on that note, let's do one. Let's do a problem. That is what we call a general region. But you know what's cool? No rush here, but look how far we are. Well, once you get through this stuff, we go back and we spend a lot of time in these sections. So we're going to spend a lot of time in 15.3. This is doing double integrals. Over what kind of regions?
General.
Over general regions. And if you want, feel free in your notes to draw a picture. What do we mean by a general region? It's not just a rectangle. Something like part of it's curving, and you can think of a sine curve, anything that's just not a rectangle. I'll show you that. So let's do one of them. Well, get a problem from section 15.3. And we'll spend some time here. Going to put a D here. So what's the surface now? The surface is just what? Z equals x squared. But the region D is bounded by y equals x squared, x equals 0, x equals 2. So we do have to do some drawing in a section of 15.3. We should draw the general region. They'll tell you where it's bounded. Can we draw that? What would that look like? There's y equals x squared. It keeps going here, but what's x equal to 0? That's right here. X equals 2. Oh, I should have put one other place. And would you write down in y equals 0? Because y equal to 0 is down here. So let's shade that in. There's your general region. You got to set that up. So I did this on purpose. I wrote x squared, even though it's the same as that. This has nothing to do with that. This could have been x to the 5th. This could have been x times y, x times sine of y. That's the surface. This has nothing to do with it. We need to set up these limits of integration. Cool. So I wanted to do that first. I want you to realize that it has nothing to do with it. So secondly, if you want, feel free to just change this to some other, we can make this something else. How about just x? Alright, you're just an x. I apologize, I think it'd even be better. How about just x times y? The surface is z equals xy. We're estimating the volume under z equal to xy over that region. So how do I set that up? This is your choice. Do you want to do dy dx? Okay, we do dy dx. Dy dx. Then these two have to be what?
Y.
Y's. And these have to be
X.
x's. So first rule with general regions, the outer limits of integration have to be numbers. I should say that right? The outer limits of integration, no matter what, have to be two numbers. This goes throughout all of calculus. We'll even do triple integrals eventually. Well, then the outer limits of integration have to be numerical values, right? So if I did this, can you tell me the two x values?
0
Just look at
to
your image, and that's why you'll make your image. You'll shade that boundary region, 0 to what?
2.
But this is what I didn't want you to mess up. Oh, if I plug a 2 into this formula, what's 2 squared?
4.
My worry is on a test, you write 0 to 4. If you put 0 to 4 here, guess what you just described? A rectangle. So I'll put it, then I'll quickly erase it. If you did this by accident, you got too much. You took the volume under this surface over an entire rectangle. We only want the volume underneath this surface over what? Over that. So this isn't going to fly, is it? Take these out. What we need are the math equations. I need the math equation here. What's that y equation? Y equal to what? And then I need the math equation for this curve. So think of it like, what's the top y equation? Whose equation on the top? And who's the equation for that y on the bottom? And those will be your limits of integration. Your limits will be in terms of like variables actually. But sometimes you still get numbers. So I'll start with the easy one. What's the lower bound?
0.
That's y equals 0. Oh cool, that stayed. But this is not 4 anymore. What's the representation of all that right there?
X squared.
Fair.
You got it. I have no idea what this answer is. You saw me make it up. Let's just see what we get. Let's see what we get. First question, can I split this up?
Yes.
No.
No.
I want to be very clear about this. I like shortcuts too, but I'm like, I can't split this up. You are not allowed to split anything up if you don't have 4 numbers. See that? General regions doesn't apply. So we are forced. We have to do this as an iterated integral. All right, so since I chose dy dx, let's roll. What's the integral with respect to y?
X half x squared.
Nice. And what are you plugging into y squared?
0 and
This
2.
is interesting. You got to plug x squared into y, and then square it. What do you get? What's x times x squared squared?
X cubed.
So close. X
No.
times
X to
squared
x to the
squared.
fifth. X to the
Nice. And then there'll be a lonely 2 down there, right, everyone? I love it. I love it. Everyone's saying you're going to get x to the 5th over 2. You got the x times the x squared squared over 2. And then you plug in a 0, and what do you get?
0.
Cool. So guess what? Now you're going to get the volume. Look, carry it down. You know you can do that as well. You get a calc 1 integral. And you're not going to find this actual volume under that surface of that region. Keep in mind, double integrals can be negative. We know that. If the surface dips below the xy point, it can be 0. So what do you get here? X to the 6th over,
Well,
let's do the 6th.
64.
There it is. Okay, we can reduce that. What's 16/3?
Yeah, 5. Hey, number 5 in the problem set. That's similar. The only difference was x squared plus y. Cool. So that was like number 5 in the practice set. That's what I mean. I'll make sure we do problem of each type. Make sure nothing shocks you. But before I erase this, you don't have to work out all the math. I was just curious. Could you set this up another way? Could you set this up as dx dy? What would be the setup? You surely could. Now if you do dx dy, I'm going to do it. So I'll put or. Now you don't have to work out the math unless you want me to. Of course, we get what for instance. There it is. But I could have set this up as dx dy. Absolutely. Now, the rule is these are limits of y and they have to be in numbers. So what are the numbers? Does anyone see it? These got to be y values. 0 to 4. And you would have had to figure out that 4. Man, wasn't given it first? Wasn't given there. You would have drawn this and gone, well, what is the y value right there? You would have said, okay, from 0 to 4. I'm put that here. These have to be numbers. Everyone agree? The outer limit. Now, these are going to be equations. Only before they were like y equal equations. Like a top y and a bottom y, right? This was like my top y and this was my bottom y. You probably recall doing something this in Calc 2 when you had to do like lines of revolution and stuff. And you had to do like, you had to either turn your head or you did right minus left. That's what we're going to do. John, you want to just turn your head like this? Or you can turn your piece of paper. I'm going to turn my head. Who's the top now? Oh, the general region there. Who's that top? It's a flat line. Who's the bottom? The bottom is that curved. So I'm going to do top minus bottom as long as I turn my what? Head. Most students are like the textbook says, you don't have to get a neck cramp. Just do right curve over left curve. Cool. So I'll go over here. Which one's on the right? Yeah, it's going to be x equal to something. That's just x equal to a flat line too. So that's a number. X equals 2. Now who's on the left side? What's the right side?
X
Let me get this top out of the way. I'm going to get my yellow chalk out here. Go. Now we're doing who's on the right and who's on the left.
X squared.
And the left is y equals x squared, right?
Uh-huh.
Do you notice z does not change? What was this before?
X, Y.
That stays the same no matter what. I just got to change my left side. Now I'm going to screw this up on purpose. The left side is that curve y equals x squared, right? What did I mess up? Yes, he goes, it should be in terms of x equal. I got to write that equation as x equal to. So if y equals x squared, hold up. What would x equal?
Square root.
There you go. Now you do not have to do all this math, Mile. I know you know how to do it. Just integrate straight to x, but you would still get what? Guaranteed, you get 16/3. Isn't that cool? So it depends. You go, which way should I do it? That's going to be up to you. I mostly do top, bottom. I think it's easier.